We've all experienced them, those strange, shadowy shapes that drift across our field of vision. They appear as tiny worms, specks, or transparent blobs. These are eye floaters, and while they might seem unsettling, they're usually harmless. Floaters appear to move, especially when we try to focus on them directly. Their elusive nature adds to the intrigue, but their origins lie within the very structure of our eyes. The human eye is filled with a gel-like substance called the vitreous humor. This clear jelly-like material occupies the space between the lens and the retina, playing a crucial role in maintaining the eye's spherical shape. It's this substance that gives the eye its shape and allows light to pass through to the retina. The vitreous humor is essential for the proper transmission of light, ensuring that we see clearly. As we age, the vitreous humor changes. Over time, it can start to break down and become more liquid, a natural part of the aging process. It becomes more liquid and can shrink slightly, pulling away from the retina. This detachment can cause the vitreous humor to lose its firm structure. This process can lead to small clumps of protein or other cellular debris to form within the vitreous humor. These clumps are remnants of the gel's breakdown. These clumps, along with microscopic fibers that are naturally present, cast shadows on the retina. The shadows are what we see as floaters. What we perceive as floaters are actually these shadows. They move as the vitreous humor shifts, creating the drifting spots or threads we notice in our vision. While floaters are always present in our eyes, they become more visible under certain conditions. These tiny specks or cobweb-like structures drift through your field of vision and are more noticeable in specific environments. Bright uniform backgrounds, such as a clear blue sky or a computer screen, tend to highlight floaters. The uniformity of these backgrounds makes the floaters stand out more clearly against the otherwise consistent color. This is because the contrast between the bright background and the shadows cast by the floaters is more pronounced. The stark difference in light and dark areas makes these floaters more apparent to our eyes. Our pupils also play a role in floater visibility. The size of the pupil can affect how much light enters the eye and how clearly we see these floaters. When exposed to bright light, our pupils constrict, effectively making the floaters more visible. This constriction reduces the amount of light entering the eye, increasing the contrast of the floaters. This is similar to how a pinhole camera works. A smaller aperture can increase the sharpness of shadows. By reducing the size of the pupil, the shadows cast by the floaters become sharper and more defined. While observing a bright blue sky, you might notice tiny bright dots darting around. These dots can be quite mesmerizing, almost like tiny fireflies dancing in the daylight. These are not the same as typical eye floaters, which are usually caused by small clumps of gel or cells inside the vitreous, the clear jelly-like substance inside your eye. Known as blue sky sprites, these dots are actually white blood cells moving through the capillaries in your retina. They become visible when you look at a bright, clear sky. The blue background makes these usually transparent cells visible. This phenomenon is a fascinating example of how our eyes interact with light and color. The phenomenon is similar to seeing the veins in your wrist. The blood vessels themselves aren't blue, but the way light scatters through the skin creates that appearance. This scattering effect is what makes the blue sky sprites visible to us. If you enjoyed learning about this fascinating phenomenon, make sure to subscribe to my channel for more positive and intriguing videos. Don't forget to give a thumbs up, like, and share.